All right, so let's go ahead and perform our t-test. So we are testing to see if there's a difference in means between our pre and post intervention data. So right now, our null hypothesis is that the mean of pre-intervention equals the mean of post-intervention. That essentially means that we're saying there is no difference in means. That's the hypothesis that we're testing. So let's go ahead and go into analyze. And like I just said, we are comparing means. This data, when you look at it, you have a participant who took some exam or whatever, and there was some intervention that happened, and then they took the same test after. So this data is paired, right? These numbers are paired and they match with each participant. So we know from that, we're trying to compare means. This is a paired samples t-test since it's paired data. I'm going to go ahead and put these back. When it comes up the first time, it'll look like this. It'll be blank. So your post-intervention is your first variable. It doesn't matter which one you choose first because this is a two-tailed test. We're testing to see if there's a difference in the means. And then your pre-intervention is second. Don't worry about this second row that pops up. We're just doing this one pair of data first, right? You can go ahead and click OK, but I'm just going to quickly show you. Your confidence interval percentage here is 95%, which means that your p-value that you're testing is 0.05. So hit OK, and then this is the output box that you saw when you first imported your data that you minimized earlier. So this is the information from your t-test. I want to first direct your attention here to the significance value. Again, because our null hypothesis is that the means are equal, we're just testing to see if there is a difference at all in the means, which means that this is a two-tailed test. It would be different if we were saying that the post-intervention scores were bigger or smaller, but that's not the case. We're just seeing if they're different. So it's a two-tailed test, and like I just said, your p-value was 0.05. So we're looking at this number here. If this number is bigger than 0.05, we would say we would have to keep our null hypothesis, accept our null hypothesis, that there is no difference. But since it's smaller than 0.05, we can comfortably reject our null hypothesis, which means that we can say we know that there is a statistically significant difference between the means of these two sets of data. Next, we just want to go ahead and double check that our means are correct, that they match up with my data here when you perform this test. You should have 20 for your sample count, and then your standard deviation and standard error of the mean should match mine. You can also find a screenshot of this information in the Word document for the instructions for this assignment. But just make sure that this information is the same. I just want to make sure that your data is not somehow corrupted or wrong, and you would know if it was if your numbers were different here. But next, we're going to go ahead and calculate the difference in our data through SPSS. So stay tuned.